4-7 is inverse linear functions. All right, so to start off, a couple definitions. So the first one is inverse relation. So an inverse relation is a set of ordered pairs obtained by exchanging, and that's the same as switching, the x-coordinates with the y-coordinates of each ordered pair in a relation. Remember that word exchanging is really the same as switching. So to kind of give you an example, if you have the point 5, 3, if that is an ordered pair of a relation, then 3, 5 would be the ordered pair of the inverse relation. That's all they mean by switching the x-coordinates with the y-coordinates. So the first example is going to give you a new relation, and it's going to ask you to find the inverse of the relation. So here's the direction. So find the inverse of each relation is really what it should say. So here's the first one. So we have the set, and this does signify a set, the squiggly braces, so those are pretty important. So we've got the set 4, -10, 7, -19, -5, 17, and -3, 11. So the inverse would be the set with the ordered pair -10, 4, the ordered pair -19, 7, 17, -5, and 11, -3, and then we close the braces. So those braces are very important. Make sure you have those braces in there to signify that it's still a set. So make sure you need, those braces. If you're not the best at drawing them, you can always just draw a squiggly line. That's fine. All right, go ahead and try letter B on your own. All right, so letter B, really no different. So it would be the ordered pair 8, -6, 11, -15, 3, 9, and 6, 0. Okay, the next type of problem they're going to give you is pretty similar, and we'll just do one of these. So here's letter C. Excuse me. So we've got still a relation, but now they're giving it to you in a t-chart. So they'll either give it to you as a horizontal t-chart or a vertical. So this one, you can either answer it as a t-chart or you can answer it as a set. It really doesn't matter. So we've got the ordered pair -4, -13, -1, -8.5, 5.5, and 9, 6.5. So if we were going to answer it as a t-chart, we can either answer it the same way they do. So it would be -13, -4, -8.5, -1, 0.5, 5, and 6.59. You could also answer it as a t-chart like this, but you can also do a set and do the ordered pair -13, 4, -4, -8.5, -1, 0.5, 5, and 6.59. It really doesn't matter how you answer it. I believe the book answers it as ordered pairs. All right, so the next example, it's going to give you a graph, and it's going to ask you to graph the inverse of the function that is graphed. So here's a relation. So I would just draw a coordinate plane in your notes, which is, draw your coordinate plane here, and then put a point at 0, 1 and a point at -1 and draw your line so that you have it. Okay, so they want us to graph the inverse. So what is graphed right now is the relation. So if I'm going to graph the inverse, your first step would be to find 2 points. And the reason we want to find 2 points is because you need 2 points to graph a line. So one point would be the point 0, 1, And then another point would be the point -1, 0. So those are points that are on the relation. So that's on the relation that's given. And so just like we did in the last problem, we need to find the inverse. The inverse would be the point 1, 0 and the point 0, -1. And once you know that, then all you have to do is graph it. So 1, 0 is right here. 0, -1 is right here. There would be my inverse. Use my straight edge and my arrows. Now, it's not always going to be perpendicular or parallel like this. So here's the second one. So again, we have a point at -1, 1. And it looks like another point at 2, 0. So we can do the same thing. On that line, so if you're putting that in your notes, then you just mark those 2 points. So same thing, we're going to find 2 points on the relation. So on our relation, we have the point -1, 1, and we have the point 2, 0. So that means the inverse would have the point 1, -1 and the point 0, 2. So 1, -1 is right here, and the point 0, 2 is right here. So there would be, whoops, the graph of my relation. So try and do a better job of what I did then. All right, so you are going to try C on your own. So same kind of thing. Make sure you graph the original in your notes so you can see. And you might want to have this in your notes even if it makes sense to you how to do it so that when you look later you don't understand how to do it. So here's letter C. All right, so for this relation, I see a point at -1, 0. I also see a point at 2, 1. Now, if you found another point, that's okay. Another point right here, -3, -1 would work. Even this one right here would work. So it doesn't really matter which one you use. So if that's my relation, then my inverse would have the point 0, -1 and the point 1, 2. So 0, -1 is right here. The point 1, 2 is right here. Connect our dots, draw our arrow, and there would be the inverse of our relation that we graphed. All right, so then we're going to talk about inverse functions. So an inverse function, remember, function is really just a fancy name for equation. So if f of x is a function, this right here would be the inverse function. So f to the -1 of x. Now we usually don't say f to the -1. We usually, this just means, if we see this symbol, this means inverse function. So what they're going to do is they're going to give you an f of x function and they're going to ask you to find the inverse. So there are about 4 steps to find the inverse of a function. And sorry, these should have been one at a time. So to find the inverse of a function, so step 1, replace f of x with y. Okay, now technically you could ignore that step. It just kind of depends on how your mind works. Step 2, interchange y with x. If you'd rather write switch y and x, that would be fine too. Just like we did with the ordered pairs, we switched x and y. And then step 3, solve for y. And then the biggest thing that people typically forget is step 4, replace y with f of x, because we're not really solving for y, we're solving for the inverse of x. So if you leave it as y, then you're saying something a little bit different. All right, so what they're going to do is they're going to give you an equation, and they're going to ask you to find the inverse of that equation or function. Okay, if the equation starts with y instead of f of x, then you're not doing step 1. All right, so here's the first one. So find the inverse of each function. So we've got the function f of x equals 4x minus 8. So your first step is to make f of x y. So replace, if you think back to those steps, replace f of x with y. Okay, step 2 then would be to exchange or switch x and y. So y becomes x and x becomes y. So those two steps hopefully aren't too bad. Step 3, we want to solve for y, so we want to get y alone. So we're going to add 8. We've done these before. So x plus 8 is equal to 4y. And then we divide everything by 4. So we end up with 1/4 x plus 2 equals y. Now, if you write that as x plus 8 divided by 4, that's perfectly fine. And so the last step is to change that to inverse of f. Now, which side you write that inverse of x equal to doesn't matter. So if you write it as 1/4 x plus 2 equals the inverse function, that's fine too. It doesn't really matter what side. Okay, so again, you could always write this as x plus 2 or x plus 8 all over 4 if you want to do that instead. All right, so here's letter B. Go ahead and try letter B on your own. All right, so your first step, y equals negative 3x plus 27. They really say the same thing. This is just an equation and this is a function. So that would be your first step. And again, if you don't do this step, that's okay. The next step would be to switch your x and your y. And then after that, we get y alone. So we would subtract 27. We end up with x minus 27 equals, negative 3y. Divide everything by negative 3. So we end up with negative 1/3 x. Negative 27 divided by negative 3 is a positive 9 equals y. So negative 1/3 x plus 9 is equal to the inverse function. So same thing with this one. If you wrote it as x minus 27 divided by negative 3 equals the inverse function, that's fine. Now, a lot of times I don't even write this step. I go right from my divide by negative 3 and I go right to this step. So it's definitely okay to do that. All right, letter C, a little bit different. All right, so for this one, same steps. So we're going to change f of x to y. And again, you can skip that step. So then we switch our x and our y. And now we need to get y alone. So to get y alone, we would get rid of the 8 first. So we add 8. So we end up with x plus 8 equals 5/4 y. So now to get y alone, we can either divide by 5/4 or we can multiply everything by 4/5. So when we do that, we end up with 4x over 5 or 4/5 x. So you can write it 4/5 times x. And then plus 4/5 times 8 is just 32/5. And then that will equal y. And I'm going to jump right to calling it the inverse of x. So that was what I was talking about in the last example. You can, instead of writing equals y and then writing it again, equals the inverse function, you can just go right to that. Again, if you write 4x plus 32 divided by 5 equals the inverse function, perfectly fine. All right, so this one's slightly different. We've done problems like this before. So now we have f of x equals x plus 7 divided by 3. So this is really y equals x plus 7 divided by 3. So our first step, or after that, we switch our x and our y. So x equals y plus 7 divided by 3. So now, to solve for y, we can't get rid of the 7 first. We have to get rid of the 3 first. So we're going to multiply both sides by 3. So 3 times x equals y plus 7. So now to solve for y, we subtract 7. So we end up with 3x minus 7 equals y, but we change that y to the inverse function, and there would be my answer. And again, you could write it on this side. Doesn't really matter which one you do that. All right, so after that, the only other way they're going to give you inverse functions is word problems. So here is example 4. So example 4, Randall wants to convert temperatures from degrees to Celsius, from degrees Celsius to degrees Fahrenheit. So I would just write this equation in your notes. So example 4, write this equation, and then letter A. Find the inverse of the function is basically what this is saying, even though it's using C. So find the inverse of the function. So we're going to do the same thing we did before. Doesn't matter if it's f of x or c of x. So they're really giving us y equals 5/9 x minus 32. So my next step, just like before, would be to switch your x and your y. So x equals 5/9 y minus 32. And now we need to solve for y. So to solve for y, we would distribute. So x equals 5/9 y minus 5/9 times negative 32 is 160 ninths. So then I would have to add 160 ninths. So I get x plus 160 ninths equals 5/9 y. There's another way we could have done this one. And now to get y alone, we either divide by 5/9 or we multiply by the reciprocal. So when we do that, we get 9/5 x plus 9/5 times 160 ninths. Your 9's go away, so you end up with 160 divided by 5, which happens to be 32, equals y. But we're not dealing with y, we're dealing with the inverse, and we're also dealing with the inverse of c. So 9/5 x plus 32 equals the inverse of c. Now if you accidentally write f of x, f to the negative 1 of x, that's fine, I'm not going to mark you wrong. Okay, so that's the equation. So then letter B, and I'm going to erase all of this, letter B wants to know what does c to the negative 1 of x represent, and sometimes they'll also ask you what the other variable represents as well. So we're actually going to label both of them. So our equation, again, I'll rewrite it, was c to the negative 1 of x equals 9/5 x plus 32. So they want to know what c to the negative 1x of x represents. Well, in the beginning, c of x is the degrees Celsius. So if c of x is degrees Celsius, then inverse c of x is the opposite, which would be Fahrenheit. And I don't care if you write degrees or not, but it would be your Fahrenheit's degrees. So if c of x is Celsius, that means in the original, your x was your Fahrenheit. So if they ask you for x in this one, if the inverse is Fahrenheit, that means x is now your Celsius. And then they'll probably ask you to solve some questions, problems related to this, and I believe there's a C. Yes, so here's letter C. Again, I'll rewrite our equation. So find the average temperatures for July in degrees Fahrenheit, and then they're giving you the minimum temp and the maximum temp, okay? All right, so remember, in the inverse equation, this is your Fahrenheit. So the Fahrenheit of x for 3 degrees would be 9/5 times 3 degrees plus 32. And your Fahrenheit degrees for the maximum would be 9/5 times 15 plus 32. Okay, So this one will give you about 37.4. Make sure you write degrees Fahrenheit. And this one will give you about 59 degrees Fahrenheit. The other way to do that is to write it into the original. So basically, they're giving you Celsius, so you'd have to plug in your Celsius here, and then 5/9 x minus 32 and solve for x. This one your Fahrenheit's already solved for, so it makes it a little bit easier to just plug in your x. So you just have to know this is your Celsius. But again, they don't really tell you have to use that equation. You could use the original. It's just a little bit more solving to do for that one.